Howdy, my name is Stephanie Aranda and I'll be presenting the Influenza A disease. This subject is covered in Chapter 23, Family Orthomyxoviridae in Susan Payne's book of Viruses from Understanding to Investigation. We will be covering the genome organization of this RNA virus as part of the family Orthomyxoviridae. One of the first things we would need to know before diving into genome organization is the structure of this genome. The genome is a segmented single-stranded negative sense RNA. For the influenza A viruses have a total of 8 genome segments. These segments form helical nucleocapsids that contain the N protein and the active RDRP, which is a polymerase enzyme complex. Now we will be covering the replication cycle of the influenza A virus. This replication cycle includes attachment, endocytosis, fusion, uncoating, transcription, splicing, RNA replication, translation, and the formation of new virions. The first step is attachment. The virion attaches to the whole cell using its surface proteins HA and NA. The HA, hemagglutinin, acts as both an attachment protein and fusion protein with a role in neutralizing antibodies. The NA, which is the neuraminidase, is a homotrimer and has a role as a receptor-destroying enzyme. The entry of the virion into the host cell is done through a process called endocytosis. Endocytosis is when the host cell membrane engulfs the virion into the host cell itself. With the virion already having entered the host cell, the virion then releases its genomic material into the nucleus for transcription and replication to occur. Once the genomes are released into the nucleus, they are then going to either one of two pathways. One pathway is to undergo transcription splicing and then released into the cytoplasm for translation. The second pathway occurs only with the nucleus as genomes undergo RNA replication. There are two groups that are based on the location of translation. The proteins M1, NP, and NS1 are translocated back to the nucleus to support genome replication. The translation of proteins M2, H1, HA, and NA are located in the ER and Golgi, as the HA and NA are glycosylated and transported to the plasma membrane to support nucleocapsid assembly. After translation and support of genome replication, the nucleocapsid assembly, now the formation of new nucleocapsids are released into the cytoplasm, thus allowing the virions to be assembled and to allow budding for mature virions. We will now discuss the antigenic drift and shift in relevance to the influenza A virus. Antigenic drift is point mutations in HA and NA. These proteins often have a role in targeting adaptive immune responses. The antigenic drift for influenza A viruses is the changing of yearly vaccines for protection against this slowly changing virus. The term drift is to imply a slow continuous process, as the term shift is used to imply larger and sudden changes. Antigenic shift is a genome reassortments that allow for larger changes in the influenza viruses that could yield to 254 possible reassorted viruses. Examples of antigenic shift are viruses that cause pandemics. The only resource that I have utilized in preparing this presentation is Susan Payne's book, Chapter 23, Family Orthomyxoviridae. And this concludes this presentation on influenza A diseases. Thank you very much and have a great day.